Hello, E3 scholars, and welcome to this edition of Sharp Shorts, where we're going to cover the integumentary system. What you see here on the left is a basic diagram of your skin, which is the main organ of the integument system. It also has accessory organs. The glands you see here, the hair. What we're not showing are the nails. Also as the accessory structures. This is our first foray into an organ system. So what I want to point out here, one of the three layers. You have the epidermal layer, which is the top layer, and that is a stratified squamous epithelium. Now remember what we said, two or more tissues makes an organ, and the skin is, depending on your measurement, the largest organ in the body. It starts with this protective layer of stratified squamous epithelium, and then below that is the dermal layer, which is actually two layers of connective tissue. There is a papillary layer right underneath, a smaller one, that is loose areolar connective tissue, and then there is a larger reticular area that is dense irregular connective tissue. Now what you also see here is the hypodermis. That is always included in the integumentary system, but it's not a part of the integumentary system. It is a cushioning, and as you can see, fat-laden layer that is below the skin, the dermal and the epidermal, the cutaneous membrane, but it is actually not a part of the integumentary system. But it does help anchor to the stuff below. And what I've listed down below here is some of the stuff, functions that the integumentary system provides. Of course, it is protection, it is the layers, it is the coverings, it is epithelial tissue. This is your skin. And so stratified squamous epithelium is there for protection. It can rub off. Now this stratified squamous is modified to include to protect the outside and waterproof it, so it has as the squamous cells rise to the top from their basal layer, they are keratinized. They are filled with the protein keratin. In fact, the cells are called keratinocytes as they go up and become that way, and that's to waterproof and seal, but prevents against abrasion in microorganisms and UV rays and prevention of water loss. There is a temperature regulation function to keep it at the normal 37 degrees or 98.6 range. There is vitamin D production. That is a cascading chemical trigger that goes to your liver, and what that does is allows the liver to produce vitamin D, which allows you to uptake calcium in the intestines. The skin receptors also come up here in the dermal papillae area, where you also see here not only skin and touch and external receptors, a number of them, but you also see the vessels that come and nourish that epithelial layer. Remember, stratified squamous is essentially dead up here, but the growth area is in the basal layer. And then there is some excretion of salts and stuff as you sweat and release sebum and oils and everything along that line. Okay. What I have here, and again, this is just a blow up, taking out essentially almost the hypodermal layer, except it's right here, and you can see the areolar tissue is marked here. This is a bigger blow up that is breaking down the layers of both the epidermis and the dermis. Like you see here, you can see in the papillary region, that is your loose areolar connective tissue, and then below the dense irregular connective tissue. Your skin is flexible, but this is also a protective area besides the attachment below the connective tissue does, besides the flexibility that this layer gives, and also has the mast cells and the stuff to prevent, that we'll talk about later with injury. But also then you have the sturdiness so that your skin can protect and be what it is. It's flexible but not too flexible. In the epidermal layer, everything here starts in the stratum basale, and actually the stratum basale and the stratum spinosum are known as the germinating strata. When you hit the stratum granulosum, at this point, the live cells should not be dividing anymore. Okay, so that's why this is the germinating layer. Everything starts here in the stratum basale, and melanocytes are down here, and Merkel cells, touch receptors are also here, and stuff along that line. But that's the basal layer, and here's the dermal papillae that come up, or the papillary region, and that's again fed by nervous tissue and circulatory system to feed these things where the mitosis occurs. Okay. This is also the area when we talk about cancers that you'll see basal cell carcinoma will start and stuff. The stratum spinosum, it's called spinosum because it's becoming spiny. You're starting to see a flattening of the epithelial cells. Again, keratinocytes is more specifically what the skin is called. And so they get a little more spiny. And with dendritic things coming out. Now we hit the stratum granulosum right in here, which you can tell from its granule layers. And that is where the cells, in theory, stop actively dividing. In squamous cell carcinoma, it often starts right around here in the spinosum layer. And what happens then is in the granulosum, as keratin is being made, and of course, as these cells become squamous and flatten out, they are divesting themselves of their internal organelles. And so they can flatten and do their protective layer. But if it doesn't stop dividing here, then you have some issues, because now you've got some dividing keratin-filled cells, and that's where squamous cell comes in. Of course, we've mentioned basal cell. Melanoma, of course, starts down here in the basale also, where the melanocytes are, and that's when the melanocytes go crazy. Now, in thick skin, you'll also have the stratum lucidum, which is, lucidum means clear layer. It's not in thin skin, but in thick skin, and really it's a buffer zone between the stratum corneum and the stratum granulosum. It's a clear layer, and again, it's really, its biggest function is to be dead cells that are a buffer zone. And then you hit the stratum corneum, 15 to 30 cells long, flattened out, dead, divested of their organelles, filled with keratin to be waterproof, both inside and outside, and then be able to scrape off in that layer. Again, I mentioned the hypodermis is not part of the integument. It does separate the integument from the deep fascia of the muscle tissue and stuff that is there. It is loaded with fat. It does help in insulation and regulation and cushioning, but it is not a part of that layer. Okay. Now, what happens? That's the basics of what this does, what epithelium is for. Now the question is, what happens when you get hurt? And I've listed the steps here, and really what it comes down to is how much damage have you done? How deep and how wide is the wound? There is a process, and this is part of the reason of having a connective tissue there, because the epithelial tissue is dead. And in that connective tissue, you have all the blood vessels that can bring all the platelets and the protein clotting factors and everything else. Plus, it's got the loose macrophages and mast cells and the things that trigger the inflammatory response, phagocytize the pathogens and surround and have the fibroblasts there to form the collagen and do the repair. And what it depends on is how deep or how wide, because you can do one thing: you can regenerate and replace and fix with granulation tissue and stuff, the reset the capillary beds and replace the epithelium and everything else. Or you can, if it's too deep or too wide, then you go through fibrosis, which is just replacement, in which case the fibroblasts make more collagen, and really it's that collagen that just holds the wound together. And that's why you get scarring. It's avascular and stuff. As you can see by the steps here, really the idea is once you get a cut, that cut itself triggers the mast cells and the start of the inflammation, which is the redness and the swelling and the stuff as the blood moves in and as interstitial fluid starts coming from cells and triggering all the stuff that goes on. Inflammatory chemicals cause the capillaries to dilate, become permeable, white blood cells and plasma fluids seep in. That's what causes the swelling. Of course, there's a little pain to the injured area. There's redness. There's an increased heat. That's included there. Some of the pain is just from that fluid pressing on the nerves. And you begin to form a clot with the platelets and the plugs to stop the blood loss and hold the edges together. There's also a walling off of the area so that any pathogens that may have come in with the wound that is exposing you now to the outside world, to try and stop that from creating an infection or spreading the infection outside. Lymphatic cells and macrophages are there to clean up all the debris and to also take care of any pathogens that came in. During that inflammatory response then, and what we're looking at is a wound that would go a little deep in, not huge, but not a scrape that is just the top layer. So, but then what happens is you get that clot, you get that scabbing coming over the top to protect the epithelium, and then all the action goes underneath, and that granulation tissue comes in, laying down new capillary beds. Fibroblasts trigger growth factors, collagen to bridge the gap and knit things together and wall off the area. And then underneath, of course, you're triggering that basal cell area to start reproducing epithelium for that area. And it takes some time. During that organization, surface epithelium begins to regenerate. And again, time-wise varies widely. But the whole idea is underneath that scab is that you are producing new cells that are bridging the gap, repairing the gap, laying down new capillary beds, new epithelium, so that when that scab does slough off after weeks, that you essentially have new tissue underneath. And here's a bit, you can link to this YouTube video, which does a pretty good job of going through it more than even we need to. But you can also look at this picture and the pictures in your book that essentially show the blood clotting and then the release of granulation tissue and fibroblasts and stuff to repair the area. Okay, so that's a quick overview of epithelium as our integumentary as a review to help you organize your thoughts and know the layers and stuff that are there and supplement your lecture. This would be a great time to hit the review sheets and do some reading, maybe watch the next video on the accessory organs. Until then, scholar on.